Hello everyone, welcome back to the Computer Networks lecture. We are going to continue our discussion in network layer data plane. Uh, especially we are going to talk about what is inside routers. Okay, so first let's have a look at the architecture overview of the routers. So first we have the input ports, several input ports here and several output ports. Okay, and in between there is a high-speed switching fabric. So basically this is complex electronics that connects all input ports into all output ports, right? And then there is another part which is routing processor. So this is doing the routing, or it's running routing algorithms, and it will result into a forwarding table, which will be used by this part, the switching fabric. So having said that, then we have this routing processor as it's running because it's running a routing, so it's in the control plane part and it's implemented in the software. And then the switching fabric, it is forwarding, it's doing the forwarding function or data plane. It is implemented in the hardware. Okay, so why it is implemented in hardware? Because it needs to work, or it needs to operate in the nanosecond time frame. Because we're dealing with the real packets coming, and then we have to forward it as fast as possible, so as to decrease any delay or avoid any congestion and so on, right? And the routing, as we said before, it's not something done in serial, meaning that when the incoming packet arrives at the router, then only it runs the router runs the routing algorithms, and then after that it get the results, and then only with that results the packet will be forwarded. So this definitely doesn't work. Okay, so basically this control plane is running in parallel, and it has the results of all the possible combinations of IP addresses and so on, and it's running in millisecond time frame. So basically it runs in parallel with the data plane. So let's have a look in more detail on the input ports functions. So okay, so the different colors here indicates different functions or different layers. The first one, the green box indicates the physical layer. It is bit level receptions, and then the blue box is the link layer protocol in the receiving part. We'll talk about that in the chapter 6. For example, when we talk about the Ethernet, protocol, for example, it takes out, it checks the destination MAC address whether it is correct, and then it takes out the the link layer header, and then go up to the network layer. Okay, so in network layers, basically there is a queuing. I mean, we'll talk about the queuing later. There are two functions, lookup and forwarding. So basically it is also called match and action, right? So matching is like we try to do lookup table from any header field values. For example, I mean the most important value is the destination IP address, for example, or it can be any field. But we talk later when we talk about destination based forwarding. Then the most important thing is the destination IP address. Okay, and then we have to look at the forwarding table, and then when we find the right match, then we will do the next action, the forwarding. So we'll forward this incoming packets with this for example destination IP address forward into the specific outgoing port. So this is lookup and forwarding, or match and action. So basically our goal is to complete input port processing at line speed, meaning that we have to do it as fast as possible. But if the datagrams arrive faster than forwarding rate into the switch fabric, then there will be input port queuing. So we can we can flash back to the queuing delay, why there is a queuing delay, and why there's congestion. So all because one of the factor is because the incoming rate arrival rate packet arrival rate is faster than forwarding rate into the Swiss fabric. So we're not, I mean, at this rate we are not talking about the outgoing yet, right? Okay, now talking about the forwarding method, we have two types, or we have two different methods of forwarding. The first one in traditional method is destination based forwarding. This is done in legacy routers or the per router control plane, where we forward. Yeah, I mean it's not just in per router control plane, but also like there are other there is a per router control plane that implements not just destination based forwarding, but this is basically it's only take a look at the destination IP address. Okay, we'll talk about this mechanism in the next slides. Okay, and generalized forwarding. So it can forward based on any set of header field values. It can be a combination of source and destination, or it can add other sub layers as we will talk about that in MPLS. I don't know if we'll have time to talk about MPLS, but there are other other header fields that can be used in the generalized forwarding. All right, so let's talk about the destination-based forwarding. This is the most common or the traditional way of IP forwarding in the router. So let's say we can define a forwarding table as follow. So and yeah, we'll talk about the structure of IP address later. But then basically, as we can already see here, IP address IP version 4 consists of 32 bits, and it is divided by 4 bytes, 30 or 4 bytes. Each byte has we call it each octet. That's why when we take a look at our IP address, it looks like this. For example, 192.168.1.10, for example. Yeah, this is just the decimal format of the original um, original binary um, representations. Okay, so we can define some range of IP addresses, destination IP address, and then for example, like for this range of IP addresses, we will forward this IP address. I mean, if we receive IP address in this within this range, then we forward to link interface number 0. And if we receive another IP address within this range, then we'll forward to interface number 1. If we receive another IP address within this range, then we will forward to the port number 2, and otherwise we forward to um, port number 3. But then what happens if the ranges don't define up so nicely? So for example, like okay, I think I have to erase this. All right. So for example, for um, the first range, this one, okay, within this range, we define another, another range of IP addresses, and we want this specific IP address within this range to be forwarded to the link, another link interface. Well, in this case, we can still, we can still have this uh, definition in our forwarding table, because if we have a look at this again, it's almost like we have this for example here, the and up to this, up to this they are the same basically, but they differs here, the next bytes. Okay, so basically we can yeah, again, I mean, whatever the case, we can still define any IP address range, and then define what is the forwarding or the outgoing outgoing port for this IP address range. So now it's this method is called the longest prefix matching. So basically, we try to match the incoming packet, the IP address. We check the destination IP address of the incoming packet, and then take the longest address prefix. Okay, that match with any any destination address range. So okay, so instead of using this, we can just if we take a look at this, basically these are the, let's say it divides here, and then we can simply change this with the stars. Okay, because it can be anything, so we don't care about this as long as it has this prefix, then we can match, if any incoming IP address has this kind of patterns, then we'll put it into this. Okay, now for this, the second one, then we can have this matching up to this part, and then okay, we just define it with the x, or don't care, like if we study in the digital system. Okay, in the next part, okay, so I will just erase this. Okay, you can also define up to this part, and then define with x the other, 1 byte. And finally this one also the same. Okay, x x x x x x. So now we have this wait just a moment. No. Okay, yeah, this is not the correct one. All right, so we divide from here because these are different actually. Right, so now example, now if we receive incoming packet with this destination IP address, for example, we can just try to match it. Okay, let's match. So basic, then this means that the first IP address will be forwarded into the interface number 0. What about the next IP address? Okay, if we have a look, okay, it matched until up to this point. Oops, just a moment. Right, but then it matches up to this bits here. Right, so this is the longest prefix that it matched to the the defined predefined IP destination IP address range. So we'll match with this longest prefix. So that's why it will be forwarded into interface number 1 instead of number 2. So this is the principle of longest prefix matching. So we start from the MSB, most significant bits, and then we take the longest match. All right, so now we'll see why long specific matching is used in the next section when we talk about the addressing, and then how it is implemented. In routers, there is content addressable ternary content addressable memory. So basically, this is the memory specifically to store addressing tables. You know. So it's a very it's one clock cycle, and then it can store 1 million routing table entries. So basically 1 clock. So it's quite fast. Let's say if we have 1 giga, 1 gigahertz clock, then it works in 1 nanosecond. If it's more, then it's like maybe it's even 2 nanoseconds and so on and so forth, or half nanosecond. All right, so for example, a Cisco Catalyst, it can store 1 million routing table entries. Okay, so I think that's it for the what is inside the router. We'll continue our discussion about the IP addressing in the next video. All right, so see you again in the next video.